Hi everyone, I'm Erich Kummerfeld, author of Causal Clustering for One-Factor Measurement Models, along with my co-author Joseph Ramsey. In this paper, we present a new algorithm called FindOneFactorClusters, or just FOFC, which is designed to discover the presence of latent variables and help you learn about them. In this video, I'll give a quick demonstration of how this algorithm works and how you can use it. Our algorithm is included in the distribution of Tetrad, which is a program that is freely available online. For FindOneFactorClusters, the focus is latent variables, and so of course it's important to have latent variables in the data generating model. In this case, latent variables are shown in these ovals, whereas measured variables, whose values and existence is known, are in these boxes. So when you have data which is generated from a model like this, right, we have our measured variables, but the lack of latent variables, since their existence isn't known, let alone the values. If you take this data set and run it through a causal search algorithm, you'll find spaghetti. Just there's lots of arrows, lots of correlations, doesn't know what to do, it's kind of a mess. Instead, you can use our algorithm, FindOneFactorClusters, which will take the data and identify how many latent variables there are, as well as which measures are children of which latent variables. So in this case, the algorithm correctly identifies that there are 3 latent variables, as well as which measured variables sort of go together, which measured variables share the same latent parents. So this has already been very informative, right? If you run this on your data and discover that there are latent variables and which measures sort of go together. But we can take things one step further by using an existing algorithm called MinBuild, which will take the output of FOFC as well as the original data over the measured variables and tries to learn a full graph, including the latent variables. In this case, we can see it already does a lot better than just running causal search directly on the measured variables, as it finds a much sparser graph, which is also very accurate to the original. In fact, it is almost entirely correct, except that it has some difficulty orienting the arrows around L2, which is just a slight error in this particular case. Anyway, I hope that this is helpful. Thanks.